We have DRL. Here's the Kim building, cross street from Irvine, corner of 34th and Spruce. Don't get there right at 9. You want to get there early. Okay, go. Welcome. Go. Ask me questions. Time is ticking. Hi. Go ahead, Ashley. You have one? Is it from a particular place that I can get a copy of it online or something? Wong, midterm 1. Tausner, midterm 1. Wong, midterm 1. I don't know. Just tell me what you want me to do. We need specifics. I don't see it. No, it's not Wong. 1. Tausner 1. Yeah? Okay. Officially, absolute value functions should be handled in the following way. When you have a function with an absolute value, this delay is too much for me. I can't handle it. 1 second. Well, it's probably going to be a delay on the other one too, but let me try with PowerPoint. So what you do is you actually write it as a piecewise function. You say, on the one hand, if the thing that's inside of the absolute value is greater than 0, it'll be one thing. But if the thing inside the absolute value is less than 0, it'll be something else. Let me explain. So we have 1 minus x over 1 plus x, and the 1 plus x is an absolute value. Here's what that means. On the one hand, just ignore the absolute value. So it'll be 1 minus x over 1 plus x. As long as what is inside of the absolute value is positive. This gets translated to say, as long as x is bigger than -1. So on this side, the function is just 1 minus x over 1 plus x. But then, on the other side, you say, okay, well, if that is negative, then I have to apply a negative to it. It's a whole fraction. I just want to put the negative out front. Let me just change the color here and put the negative out front. If you want, I can say -1 times if that helps. Okay, and this is true if the thing that's inside the absolute value is less than 0. This translates to say if x is less than -1. So we have two different identities for this function, depending on what values of x you plug in. And so now let's answer the limit question. You're asked, well, what happens as you go towards -1? We've defined what's going on the left hand and what's going on the right hand. So let's see what happens. As you go towards -1, from the right hand side, what happens with this function? This is my right-hand side, and this is my left-hand side. What happens as x goes towards -1? The limit as x approaches -1 from the right-hand side of f of x is going to be using 1 minus x over 1 plus x. Can you argue to me, telling me what happens with this function? Think of a number very close to -1, but on this side of -1. Think of a number like -1.0000, no, sorry, -0.0000, I guess 99999. I'll get it eventually, I'm sorry. A little slow waking up. What's going on with the denominator? Is it positive or negative? Is it big or small? Just give me some kind of general description of it. Positive or negative? Positive and small. Okay. It's approaching 0, but it's positive. The denominator is. What about the numerator? What's going on with the numerator? As you go towards -1, in your mind, think about a number like -0.9999. What is it approaching? It's approaching 2. Very good. And it's approaching 2 from a positive. It's positive and approaching 2. All right, very good. Now, let's argue. What happens if you have something that's positive and approaching 2 in the numerator and positive and approaching 0 in the denominator? What's going to happen with that? It's going to be infinity. Positive infinity. Okay? So that's why, from the left-hand side, the function is approaching positive infinity. Same thing for the right-hand side. Let's argue. That's from the right-hand side. I'm sorry. From the right-hand side, we have that. Now from the left-hand side, x approaches -1 from the left-hand side. How does this change? We have 1 minus x over 1 plus x, and now -1 times that. Okay, so now we're going to think of a number like what I had before, -1.00001 or something like that. What's going on with the denominator? What's it approaching and what sign? Approaching the sign on it is going to be negative. Worry about this guy later. Hold on one second. It's just as far as the denominator is concerned, the sign on it is going to be negative and it's approaching 0. Very good. What about the numerator? Okay, the sign on it is negative, and it's approaching 2. Very good. But the sign on it is positive or negative? All right, if you want to consider, okay, yeah, so if you want to put that in there. Okay, so wait, you want this to go up here? Okay, I'm just going to put, okay, fine, we'll go with that. So, if we take the -1 times this guy here, that's going to be negative. Okay, and approaching 2. Now let's argue what's happening here. Numerator, negative approaching 2. Denominator, negative approaching 0. What's going to happen to the function? What's going to happen with this limit, I mean? Is it negative infinity or positive infinity? Positive infinity. Positive infinity. Now, according to the way he discussed limits, we're down to one of these three answers because we get the answer infinity. We got the left-hand limit going to infinity and the right-hand limit also going to infinity. So, according to his description of limits, he says that when this happens, the limit doesn't exist, and he has to give a reason. What I had said was that the limit was infinity, but he feels that it should be more finely worded as it doesn't exist because it's infinite. So it's saying the same thing. So we answer that the limit does not exist because it's infinity, according to his test. Okay, if this was on my test, I would say the limit's infinite because the left and right hand agree. Okay, so when you encounter absolute value, technically you should go about this splitting based on what is inside of the absolute value and whether it is positive or negative. Okay, if you want to get precise and very particular about it. Okay, and this is from Tausner exam number 1. Sorry, I should have said that a long time ago. It's question number 4, I think. And does that answer your question? Okay, great. Yes. Fall 2009, number 1. Okay, it says the following. If you know that the area under the curve f of x from 0 to 3 is 12, that's how you translate that. And the area under the curve from 0 to 6 is 42. So you have some function or whatever, and the area under the curve from 0 to 3 is 12. The total area under the curve from 0 to 6 is 42. Okay, then answer the question. It's part of this, but answer the question, what must be the area from 3 to 6? 30. Very good. We learned property of limits that if you find something in between the A and the B, and you split it up, then the area from the A to that C, and the area from that C to the B should be the total area. Okay, great. So now let's attack the problem that they ask. It says, okay, well, what about the area from 3 to 6, not f of x, okay, but twice f of x, minus 3. So we could actually take this function and shift it down 3 and double it or whatever. We don't need to do that. We're just going to apply the property of integrals that we talked about. That if you have a constant, okay, well, first off, if you have two functions that are added together, I think that we should break it up into two separate integrals. So that's the first thing. The second thing is that, well, if you have a constant in there with the function, you can pull that constant out. So 2 times the area from 3 to 6 on f of x minus the area from 3 to 6 on 3. And we've already said that the area from 3 to 6 is 30. So we need to double that. And from that we need to take away this simple integral. Why is it simple? What function has 3 as its derivative? The antiderivative of 3 is 3x. So 3x evaluated from 6 to 3. It's 3 times the difference between them, which happens to be also 3. So this is a 9. The answer to this question is 51. That's all it is. Okay. Properties of integrals that we apply generically to show that we understand what's going on. Any more questions about this one? No? Okay, sure.
Maybe let's bring 20 times over time.
Spring 2010. Question number 10. Find the absolute minimum value of this function. Has trig in it. And you have an interval, 0 to pi. First thing I want you to do is make a chart. See, because absolute minimum value comes from evaluating the function f of x at the endpoints, or possibly any critical numbers in between. Okay. So get some points by just plugging in the a and the b. You don't want to lose those points. If you plug in 0, what's the function value? Because sine of 0 is involved, so 0. If you plug in pi, what's the function value? Because sine of pi is involved, it's 0. Okay, chances are the absolute minimum value is not going to be 0. Maybe. Let's think. Possibly. It could be. Okay. So let's search for critical points in between. They come from where the derivative is either undefined or equal to 0. Let's take the derivative. Using what technique? Product rule. It's two functions multiplied by each other. The function is 2 times the sine of x times the cosine of x. Alright. So to show that you know the product rule by executing it. And then the hard part is analyzing it. Try out where it's equal to 0 at. It's never undefined. We'll find it out in a second. Derivative of the first is 2 times the cosine of x. You multiply that by the second. Cosine of x. Put a plus sign and reverse that. Leave the first alone and multiply by the derivative of the second. Derivative of cosine is negative sine. Sometimes I even like to write it as -1 times the sine of x, just to remind myself. In the end, we're looking at 2 cosine squared x minus sine squared x. Let's go ahead and factor that 2 out. I need to know where this is equal to 0 at. It's always defined. There's never a place where this would be undefined at. Undefined pretty much comes from having some denominator that's equal to 0 or something of that nature. So here's the hard part of the problem. Solving this trig equation. So at least have the framework. At least have this thing set up. Points for that. At least be able to take the derivative and know what to do with it. Points for that. And now the rest of it is trig. Can we solve this? And how? There are seats here. You don't have to sit on the aisles. This is the biggest room I can get on campus. I'm sorry. I guess I waited too late to reserve the room. But there are there's at least 10 seats in here if you want to jump over people. You don't have to sit on the floor. This is equal to 0 if this guy is equal to 0. Or you could think about this as like having a squared minus b squared, really. The difference of squares. It is a plus b times a minus b. That's one way to think about it. You don't have to, though. It is cosine x plus sine x times cosine x minus sine x. But we only really care about one of those. This one here, cosine x plus sine x equals to 0, means that the cosine is opposite the sine. And that happens multiple times, but in the interval from 0 to pi, it happens only once. When cosine and sine are different signs with the same value, it's at 45. That's in the second quadrant. What angle is that? 3 pi over 4. 3 of those 45s. Okay, what about this guy? That means they're the same. And of course, that's at pi over 4. Okay, so actually, we need both of those. We need pi over 4, and we need 3 pi over 4. And our answer actually comes from that 3 pi over 4. Because at pi over 4, they're both positive, right? The sine of pi over 4, same as the cosine of pi over 4, it's root 2 over 2 at pi over 4. So you're going to take and plug them back into the function. The key is the function, f of x, back to f of x. So you need to take and double root 2 over 2 times root 2 over 2. Okay, I don't care how you do it, but I would do it like this. And then I take these two together and cancel this. So the answer is 1, positive. While over here you'll get a negative 1. Because at 3 pi over 4, it's the cosine that flips and turns negative. And so that's going to be a negative 1. And there's your absolute minimum value of that function. Questions about this one? Yes?
Just some general questions. So when they ask for the absolute minimum value, they're referring to the y value?
Oh, 100%. 100%. You get points off if you give me the x. If there was 3 pi over 4 here and you took that answer, technically you get points off. Value of the function. It's a y. Okay? Done with this one? On to the next one. Jeez. What do we do, make a list or something? I don't know. All right, we're going to make a list. Fall 2007.
Spring 2012, number 5. Walk, Jan 1, number 6. Number 3. Spring 2012, number 8.
Cover something not on the plan. Somebody cover something not on the plan. 20 or 19? I don't know what it is. Wait. We're not there yet.
Oh, I was going to say, you didn't pencil it.
Don't worry, we won't get to the end of this list, but I will finish the list somehow, some way. Yes. Number what? Okay, fall 2010. Question number 12. A particle is moving along the y equals x squared. As the particle passes through the point 2, 4, x is 2, y is 4, its x coordinate is increasing at a rate of 2 centimeters per second. We translate that to say that dx dt is 2. How fast is the distance from the particle to the origin changing at that instant? Okay. When faced with the related rates problem, what you need is an equation for the thing that you are trying to find how it's changing. Now, it says distance, the particle is from the origin. How fast is the distance the particle is from the origin. Distance the particle is from the origin. Distance formula. Any point distance from the origin is found by doing the square root of the x coordinate minus nothing squared and the y coordinate minus nothing squared, because the origin is 0, 0. You just subtract and square. So the distance is equal to the square root of x squared plus y squared. That's the distance. I shouldn't use d, but you know, that's what it is. D, distance. Distance any point is from the origin. At the instant when x is 2, and y is 4. The key is not to plug in 2 and 4 and get that distance. We don't want to know what the distance is. We want to know, this is going to be bad for me to write this, I'm sorry, but how the distance is changing with time. Sorry about that. dx dt, dy dt, d dt. Sorry. Can I use capital D or something? I don't know. I don't know. Let's go with this. Now, the x and y are actually related to each other. We know that y is equal to x squared. So how x is changing will affect how y is changing. In fact, you know what? Why don't we just make this a single variable function? If y must be, this isn't just a random point out in space. This is a point that's traveling along this curve, y equals x squared. So why don't we just say that y squared is x to the 4th? And have this thing be just a single variable function, x squared plus x to the 4th, sorry. And please don't do the tempting thing of taking the square root of each of those. I see some of you guys doing that on the exam. It's not true. If you have a plus b and you have a square root of that whole thing, you can't take the square root of each. We have this function based on x only, and we want to take its derivative and find out how it's changing with time. Okay. And so we take the derivative of it with respect to time. I'm sorry with the two d's next to each other. I apologize about that. It's a root, so we take 1 over 2 square roots. But then chain rule says you're not done there. Take the derivative of the inside, which is 2x times dx dt and 4x cubed times dx dt. You don't have to do it this way. I mean, the way I decide to do the problem is not necessarily how you have to do the problem in this case. But this is what I get. All right. I know dx dt. I know x. Well, the only thing I need really is to plug in now. I have 2 times x times dx dt, 4 times x cubed times dx dt, all over 2 square roots of 2 squared plus 2 to the 4th. I'm just going to plug in and get that number. And that's the answer to the question. Related rates, this is what this question is. Okay, I'll let you figure it out from there. Okay. Questions about that before we move to the next? Yes?
Why did you square what the y the x was?
My formula had y squared in it, so I just wanted to know what y squared was in terms of x, so I squared. Good question. Please, there's no question that you shouldn't ask. If you have a question, ask it.
Could you also do it by like drawing a triangle and then use the distance?
That's probably better. The distance to the origin would be a z distance. We have an x distance and a y distance. You don't have to worry about the square root in my case. In your case, sorry. In my case, you have to worry about the square root. I like your way a lot better. Anything else about this one before we move on? Yes?
How
we get this 2. 1 over.
There's lots of 2's there. Which one are you talking about?
1 over 2 multiplied by.
Oh, so derivative of a square root of anything, I like to think about it as like if I have some function that has the square root of some other function, you can think about that function as being to the half power. Power rule says you should bring that half down in front and take it to the negative half.
Oh, yeah.
I skip that step and I automatically go 1 over 2 square roots of the. So when I go to take the derivative, I skip that, bring the half down, and I just go immediately into this here. But that's where it comes from. You bring the half down and you take it to the negative 1/2 power. But then there's a chain rule, of course, too. Okay, let's move on. Townsend midterm 1, number 12. Unless there's something pressing about this one. Make sure you get the same answer that they say it is. And if you like the other way, try it. I just don't have time to do it probably 2 different ways. So, but I definitely like the other way. Next up is Townsend midterm number 1, question number 12. Show that there's an x value such that the log of x is exactly equal to 1 over x. There's some things hidden behind the scenes. Let me reword it for you. Show that there is an x such that ln x minus 1 over x is equal to 0. No? Okay. Show that there is an x. Show that there is a root of this function. Does that help? Hidden behind that is the intermediate value theorem. What is the intermediate value theorem? In this sense, used in this sense, where we have the ability to be able to find the root. Not exactly know what the root is, but to know that there is a root. Yeah.
The boundary is b and I, like one has to be negative, one has to be positive, so that that definition has to be access.
Okay, so we're missing an A and a B, but we can just go get ours. Usually they're given to you, but we can just go get ours. We need to go get an A and B. And here's what we need. Oh, well, the only thing you need to be able to use the intermediate value theorem is that your function is continuous. You need the function to be continuous on the interval that you're trying to find your AB. Okay, so the only issue we would have about this function is that you can't plug negative values into the natural log. Okay, so we can't talk about negative x. And you can't divide by 0, so we can't talk about 0, x equals 0. But any other x is fair game. Okay, what I'm discussing is the domain of this function. Okay, the domain of this function is anything greater than 0. So when we go to try to find our A and B, we can only pick things that fit that. You cannot plug a negative into it. You cannot plug 0 in. But anything else is fine. And we have to do the work. We have to know it's going to be negative on one side and positive on the other side. So we have to know about the log function. and know where it's negative at and where it's positive at compared to 1 over x. And so really the main thing you need to know about the log function is that it dives to negative infinity as you approach 0 from the right hand side. When you get to 1 for x, it is 0. It is negative between 0 and 1. Okay. It is negative. And then I guess one last thing is that if you get to e, it's equal to 1. That's about it. This is a log x function. That's what you need to know about log. That the log of 1 is equal to 0. The log of e is equal to 1. And if anything between 0 and 1, the log of it is negative. That's about it. And it grows very slowly. Okay, so we use this to help us pick an intelligent choice of x equals a and x equals b. Go. Oh, and that e is about 2.7. That might help out. I don't know. Like pi is about 3.14. Okay, got something? What do you got?
And could you maybe pick an a that's less than 1?
Okay, you got one?
Then b that's greater than e.
Ooh, sounds good. She has a good strategy. Pick an a that's less than 1. And pick an b that's bigger than e. Let's try it out. Pick an a that's less than 1. Without knowing, anything for sure, if you pick an a that is less than 1, in turn, we can be sure that the sign is going to be... We pick it smartly, though. We're going to pick something between 0 and 1. I like the idea. Pick something between 0 and 1. Pick it smartly. Anybody have anything? No? It's okay. Yes?
I go root of e.
You pick root of e. That's what you want to use? Oh, you want to know? Oh, you want to solve it. Show that there is an x. Oh, you want to solve this equation. I'm just making sense. I'm trying to understand what you're saying. You say you got root of e as the answer to the root? And you got that how? That's going to get you no points. It's good. And maybe even right. The how is what we need. And this is it. Jack.
Would it help at all to rewrite that function as x ln x minus 1 equals 0 so that it's an easier translation of actually what it looks like?
X ln x equals to 1. X ln x minus 1 equals to 0. So Jack says, I don't really like how this function is ln x minus 1 over x. I'd like to rather think about it as x ln x minus 1. Okay, how does that? Yes?
Well, if you're trying to pick a value of e between 0 and 1, and if e is like 2 point something, then what if you make your value 1/52?
Okay. So the idea has come on that we should say, what if we choose 1 over e? Let's see what happens. What is the ln of 1 over e? It is the ln of 1 minus the ln of e. What's the ln of 1? 0. What's the ln of e? 1. It is negative 1. Very good. The ln of 1 over e, negative 1. Let's put it on the list since we have a cheat sheet. The ln of 1 over e, negative 1. So we don't have to ever do that again in our lives. Nothing wrong with that. That was actually good. Okay, now, wait. That's not the whole function, though. The whole function is the ln of that, or I'm sorry, let's use Jack's, okay, so we're getting a negative 1 minus e. That definitely is less than 0. 100% less than 0. Okay, now pick something where I can make sure to know that it is positive. E? E? Let's choose E. What is f of E? It is the ln of E minus 1 over E. Ln of E is 1. 1 over E, that's only like a half or something like that. It's positive, whatever it is. Okay, we have it. We have it negative 1 over E. We have it positive at E. This is our A and our B. By the intermediate value theorem, we are sure that somewhere, I don't know where, he knows where. It's very good. It's equal to 0 somewhere in there. That's what he wanted you to do. Yes?
What would stop you from, when you know the graph is ln of x, and you know what the graph is 1 over x looks like? Because the graph is 1 over x has a vertical asymptote at x equals 0, and a horizontal asymptote at y equals 0. Like the positive part of that graph, you can see where it intersects. You can see that it has an asymptote conflict.
ln x, 1 over x. I can see that. I know what that is.
They intersect.
Yes, they do.
Can you say that they do equal, they have an x in common in one place?
It's not enough.
No, no.
They do have a common point. You sure about that Rudy answer? I'm doubting the Rudy answer. Yeah, it's close, but not quite. Okay, good. Next question. Long midterm 1, number 8. Boy, this is repetitive. Now we see it. Oh, it's 2 roots. Okay, find 2 intervals. Intermediate value theorem. I don't know who asked this question, but I'm going to move on. Okay, next up on the list. Fall 2010, number 5. It's getting repetitive. Next question. Spring 2012, number 5. Find the area of the shaded region. Okay, it's the area between curves. It's the upper curve minus the lower curve. At first, it is x minus x squared over 8. So long as you're between 0 and 2. But then when you get to 2, it switches. The upper curve is now something different. When you get to 2, the upper curve switches, and the upper curve is now 2. Lower curve still the same, x squared over 8. Do these two separate integrals and you'll get the answer. It's okay, I don't do it. I don't know who asked this question, but I'm going to move on. Yes?
You still get points if you flip it or solve for y.
You'll still get points if you flipped it and solve for y. Flip it. So, if y is equal to x squared over 8, then 8y is x squared. X is the square root of 8y. For this part, over here would be the negative square root. And so you have a right curve and a left curve at that point. And you'll be integrating from 0 to 2, the right curve minus the left curve. Square root of 8 is 2 root 2. That was fall 2010, spring 2012. Long midterm 1, number 6. If you were at our last review, we did this problem. I'm just going to take it as far as setup, and you have to take it from there. This is not 0, although it looks like some large number minus another seemingly large number. It's not 0. It is infinity minus infinity. It's indeterminate form. So we need to create a fraction and perhaps use L'Hopital's rule or something. I don't know. So it turns out that it comes in multiplying by the conjugate. So I have this root of x squared plus 3 minus the root of x squared minus x. I'm going to take that as an entity of a fraction over 1 and multiply it, both top and bottom, by the conjugate, which is the same roots, except for we change the sign that is in between them, not underneath, in between. Most people that get this wrong, they understand that they have to do it, but they don't do it to the denominator too. They forget about that. And you're physically changing if you multiply by something without also dividing by the same thing. And so when you do this, it works out. You get x squared plus 3 and x squared minus x, technically with a negative 1 on the outside there, so that it applies to both of those. And then you still have this denominator. And you're doing the limit as x gets big, so that the x squares cancel out. I'll let you finish it from there. You end up at this point where you have 3 plus x over that same conjugate. But it may not be best to think of approaching this with L'Hopital's rule. You might end up in some loop that you'll never get yourself out of. The best way to approach this is algebraically. And I'll just tell you what it is and we'll move on. It's multiplying both top and bottom by 1 over x. But the 1 over x from the bottom, call it 1 over the square root of x squared, so that you can incorporate it into the two roots. We're going to move on. Yes?
So if we saw that, we would just have to know we kind of keep doing L'Hopital's rule, or we could do it.
Yeah, time is of the essence, and you don't want to. It's gonna kill your time, and you might not even get anywhere. Yeah.
Two questions. First, could you argue that as x, so if you have that step over there, on the right, as x gets big, the 3 underneath the root on the bottom becomes insignificant, and the x becomes insignificant, so you end up with x over 2 root 2x squared, 2x.
It's a good argument. Just need to see some algebra behind it, though. You can use whatever you want to use. We won't tie your hands behind your back and say you cannot use L'Hopital's for this question. Yes. Okay. So what's not on it? What didn't we do? So 7.3 is hyperbolic trig functions. We didn't do it. You're right. (2.3) epsilon delta proofs of limits. It showed up on last spring's final, but not on this. 4 point. Gosh, I'm gonna get this number wrong. Newton's method. I don't know what it's called. I don't know what section. 4.7. Thank you. Newton's method to help you find roots. (5.2) Riemann sums. The actual definition of what's behind the integral. We covered it briefly, but I did an example in class of how to solve a limit with the sum. Okay, that list is complete. Long midterm number 1, question number 6. Question number 3. Now that we know L'Hopital's rule, I might attack this with L'Hopital's rule. At this point, they didn't know L'Hopital's rule, so they had to do some clever rearranging. But this is definitely 0 over 0. So I would attack this with L'Hopital's rule. Okay, if you'd like to know the clever rearranging, I could do it. Their hands were tied behind their back at that point, and they were not allowed to use L'Hopital's rule. They didn't know what a derivative was at that point. So it's okay, in the interest of time, that I don't spend time here talking about that. You can send me an email, and I can write it up if you want. But I'm going to spend time here talking about it using L'Hopital's rule. Did that recording stop? Okay, I guess we're good. So we have 0 over 0. Tangent of 0, 0. Sine of 0, 0. So what does this get you? One time through, it gives you secant squared of 9 theta times 9 cosine of 2 theta times 2. L'Hopital's rule. Derivative at the top, derivative at the bottom. Chain rule. I don't know secant, but I know cosine. The secant of theta is 1 over the cosine of theta. So the secant squared on theta would be 1 over the cosine squared on theta. So if you want, you can rewrite this as 2 times the cosine of twice theta times the cosine squared on 9 theta all underneath a 9. Cosine of 0 is 1. The answer is 9/2. If you are really hung up and you want to see the other way, please just email me. Next question. Spring 2012, number 18. Okay. On our list of things that we didn't cover is epsilon delta proofs of limits. And on spring 2012, number 18, you'll see one of those. So we'll move right along to next on the list. Spring 29, number 11. This is pretty efficient. We're doing pretty good. Yeah. Okay. After. So they call it capital F of x. It's the area accumulating function under the graph of f from 1 to x. This thing accumulates area under the graph of f of x, above the x-axis, from 1 to x. So what is f of negative 2? The symbol for it is the integral from 1 to negative 2. That's backwards. The upper limit is larger than the lower limit. So we put a negative sign out front, and we do from negative 2 to 1. That's a nice rectangular region with a base of 3 and a height of 2, 6. So negative 6. F of 6 would be the area from 1 to 6. Someone say the area, the answer to it says positive 6. The answer is definitely negative 6. Sorry about that. That's my fault. And there's max twice? That's typo. That's laziness. That's my fault. I'm sorry. I have to apologize for that. This is when? Spring 2009? This should be a negative 6, and I'm thinking this should be min. Sorry about that. If that's the only reason that you wanted to ask this question, then we can move on. Who asked this question? We're good? Keep going with it? C? Skip down to C? B? Oh, let's keep going. So we have 1 by 2. This is 2. This is 1. So this is an area equals 1 triangle. This is one large triangle with a base of 4, height of negative 2, 8. Half of that is 4. The area is negative 4 here. 1 and negative 4 total. To be negative 3. For what values of x is the function increasing? The function's increasing when its derivative is positive. What is its derivative? The fundamental theorem of calculus says that its derivative is this inside function. F prime of x is f of x. Fundamental theorem of calculus, part 1, according to our textbook. So, if I want to know where its derivative is positive, then I want to know where f of x is positive. if I'm looking at a graph and I want to know where it's positive, that's where its graph is above the x-axis. Wow, I don't know what happened there. So, respond that -2 to 2. Now, the maximum value of the function and the minimum value of the function is the largest the function ever gets and the smallest the function ever gets on the interval. Right? If you want, throw the word absolute in there. Okay, so it could happen at -2. It could happen at 6. It could happen at any critical number in between. A critical number in between would be a place where the derivative is 0, but the derivative of 0 is where the function f of x is 0. And that only occurs at x equals 2. These are your options for absolute max and min possibilities. We've already seen that at -2 we get a -6. At 6 we get a -3. And at 2, what are we going to get? -5. No, wait. 1, +1. Geez, what am I talking about? So the maximum value of the function is 1. The minimum value of the function is -6. Treat it like an abs max, abs min problem. Question?
In B, does it still increase even though it goes backwards, like from 1 to -2?
The area is increasing. It starts at -6 and it increases, gets more and more.
But when we go back, we don't do like flip the sign.
When we go back, we flip the sign. So, do you agree that the area, we go back to -2, the area is -6. Do you agree with that? If we go back to -1, the area is -5. Oh no, -4. From -6 to -4, you increased. If you go back to 0, the area is -2. That's increasing. You were at -6, then you were at -4, now you're at -2. You are increasing. So f is increasing from -2 to 2.
Oh, it doesn't start at 1, it starts at the like...
I mean, its definition is that it's the area from 1 to x, but it does go backwards. So it can start at any x value. If I had more x's, I can go back even further. I'm only looking at -2 to 6. I can go back to -2. If you're looking at a chart of values for capital F, at -2 for x, you get -6. At -1 for x, you get -4. At 0 for x, you get -2. This function is increasing.
So we look at that, we don't look from 1, we look from the like, from the furthest to left.
I want to know where f is increasing, and I get increasing y values for these x. Try to move on.
How did you do the one? Like, where do you plug that into?
What is f? F is the area from 1 to x. What did I plug 1 into? What did I plug 2 into? I plug 2 into my function. I get the area from 1 to 2. Which is that triangle area of 1. We really need to move on. Go ahead.
I wanted to ask how you got -2 and 2.
How did I get the -2 and 2?
Yeah.
I treat this as my A. I treat this as my B. So I have an A and a B, and I try to find critical points in between. I treat it exactly like the absolute max, absolute min value problem. You have to evaluate at the endpoints. It could happen there, or it could happen at any critical point that's in between. And you just make a chart. Yes?
Is it okay to solve C just geometrically?
Is it okay to solve if you give a good enough explanation? You have to convince the person. That if you're making an argument, like when Jack is making an argument, you have to convince the person, and you have to use mathematics. You can't. I mean, it needs to be sound argument. I just think this is the best way to do it. But it depends on who's grading it, basically, at that point. If you just want to give an argument, if that person is convinced, then they'll probably give you the points. We really need to move on. Yeah.
Are you going to be one grading on midterms, or should it just any one of the midterms?
Say it one more time.
Are you going to be the one grading on finals, or is it going to be
Am I going to be the one grading your final?
like you or the TAs?
Yes. Next question. Drew Rosenhaus. Townsend midterm number 2. Question number 8. What's dy dx at 1, 1 if this function is what we're looking at? Y cubed minus x log y plus x equals to 2. You cannot solve for y. You don't just take a derivative. You have to do it implicitly. So 3y squared dy dx, or y prime if you want. This term here is the one you focus your attention on. It's the one that has both x and y in it. You have to do a product rule for that. This minus complicates things. I recommend just leaving the minus there and dealing with the product rule as if they were positive x and log y. If this guy's your first function and this guy's your second function, you go to take the derivative of the first times the second plus the first. Here we go. The derivative of the second, don't forget, y prime times that. Plus a 1 equals 0. Don't make it 2. Some people make a mistake of just copying down the right-hand side. You're taking the derivative of both the right and the left. So you get a 0. My recommendation, plug in x and y right away, right now. Don't try to do the algebra without the x and y. Plug them in. You're interested in this exactly when x and y are both 1. Plug in that. 3 dy dx minus the quantity of 0 plus dy dx plus a 1 is equal to 0. And that's just so much easier to deal with than having the x and y's in there. How did I get to 0? The log of 1 is 0. 1 over 1 is 1. Well, if I have 3 dy dx minus dy dx, I have 2 dy dx equal to negative 1. So I have the answer. Okay, plug in immediately. Next question. Wong, midterm number 1. Number 1. I didn't label that, I'm sorry. That was Tausner. Midterm number 1. Number 8. Oh, I'm sorry. Tausner midterm number 2. Okay. E to the 1 over x as x goes towards 0 from the left-hand side. When you're doing right or left-hand limits, it's helpful, not totally necessary, but helpful to think of numbers that are very close to your number, but on the side that they want you to be on. And so I should think of a number like negative 0.00001 or something like that. If I raise e to that, what's going to happen? So this fraction here is 1 over a very small number, but negative number. So this is going to approach a very big number, but negative in sign, though. But e is raised to that. E to the x looks like this. And so the closer and closer you get to 0 from the left-hand side, the more and more you basically are trying to find the value of the function as you approach negative infinity. Trade the question in for that. So we say 0. Approaches 0. As x approaches 0 from the left. Yeah. Long midterm 3, number 5. Any questions about that one? That was fine. Right on time. Let's mess with you. Good thing is I'm recording it, so you're all good. We did this one at the last review. It wasn't recorded. I'll get it started. It takes a while to process it. It's 2 hours of HD film. But when I, right after class, I attempt to upload it. I just don't know how long it's going to take. I'll send the class email out. If you're not in my class, just send me an email. $17 points. Sale price of an item is equal to 100 minus 2x. Let's use P. And X is the number of items. Then he talks about cost. The cost is 4x plus 200. Okay. X is supposed to be something between 0 and 50. What's the number of items should be manufactured in order to maximize the manufacturer's profit? So then he talks about something different. Profit is revenue minus cost. You definitely have cost. 4x plus 200. You do not have revenue. Revenue is price times quantity. And so you replace price with the demand equation, with this equation here that tells you how price is related to quantity. Replace that with 100 minus 2x, but don't forget to times it by x. And you've built your profit function, and you want to maximize this. Now, it's nice, though, they give you the bounds. So we'll turn it into an absolute max problem. 0, 50, and then any critical number in between. That'll be our proof of that we have maximized it. I'll let you finish this. Is it okay? Yes? Yeah, he didn't provide answers. I can work it out for you. Long midterm 2, number 3. You can't see my facial expressions on the video. But I just said that, so you might. Ready? Now here's a piecewise defined function, and we're asked, where is the function not differentiable? Okay, not differentiable. Differential means you can take the derivative. So not differential means you can't take the derivative. The derivative doesn't exist or something like that. Not differentiable. So how can you be not differentiable? A cusp, sharp point, discontinuity, a jump, or an infinite, or a removed point. I don't think we have any removed points, but a jump, discontinuity, and infinite discontinuity. All these are definitely ways that you could not be able to take the derivative. Now, these cusps, the sharp point thing here, this is about basically your derivative being one sign coming in and some other sign going out. So you have a positive derivative, and then all of a sudden it flips and becomes negative without, going through 0. That's what's going on here. Anyway, so let's deal with the discontinuity part first. If you're not continuous, you don't have a chance to be differentiable. So let's check for continuity. When viewing these functions, I recommend breaking up the number line to give the identity of the function. If you see this symbol, remember it's called arctan. So it's 1 plus the arctan of twice x, as long as you're smaller than 0. If you're between 0 and 1, it's e to the 2x. If you're bigger than 1, it's x cubed plus natural log of x. Oh, this is... Okay, what we're concerned about is where this thing would fail. Now, let's first decide on the points where the function is broken up into. At x equals 0, what's the function going to from the left-hand side. What is the arctan of 0? Plus 1. So this function is going towards 1 from the left-hand side. And e to the 0 is also 1. So as far as being continuous, yes, it's continuous. We're continuous at 0. Good job. But at 1, it should be blatantly obvious that it's not continuous. You don't have to consider that at all. Right? As you go towards 1, this function is e squared. But this is not. It's 1, I don't know, 2 or something. Not continuous. So, not differentiable. Okay, but there's a lot of answers that have 1 in it. So we have to also see about what's going on at 2, apparently. Because anything that says 0, we can rule out. Oh, actually, that's a lie. Let me go back. Sorry, I didn't say that. You didn't hear me say that. We have to check the derivative. I'm sorry. You didn't hear me say that. I didn't say that. It's continuous there. Anything that doesn't have 1 is a bad answer. That's what I meant to say. I flipped it in my mind. Anything that doesn't have 1 is a bad answer. That's what I meant to say. I'm sorry. And this. Okay, good. Now it's a question of is it 2 or 0 involved? That's the answers that are left. 2. Why 2? There's nothing about 2 as far as breakpoint. The 2 is about the absolute value. The question is like what that does at 2. Okay. Basically, we have to do it again. We have to think about it being split. At 2, the function changes. It's x cubed plus log x plus x minus 2 as long as x is bigger than 2, and it's x cubed plus log x minus 2 as long as x is less than 2. And we're going to get different values. Or not, I don't know. At 2. 8 plus log 2 plus 0, 8 plus log 2 minus. So it's continuous there. It's continuous there. At 2 is continuous. Okay, great. So it's in the list. Possibility. Okay. Now we have to check the derivative. If there is a derivative, it would be this. 1 plus 1 over 1 plus 2x squared times 2. Arctan's derivative. Oh, 0. Jeez, what am I talking about here? I'm so sorry. If there was a derivative, that would be the first part of it. And then you hit 0, and it flips to be 2e to the 2x. You hit 1, and it flips to be 3x squared plus 1 over x. And then we have to deal with this part. If you take the derivative of this part here, this x minus 2 part, if you just look at that part, it's 1 on the left-hand side of 2, but it's negative 1 on the right-hand side of 2. Oh wait, I got that backwards, I'm sorry. So the question is then, what about its derivative? Will they agree? If you plug in 0, it's going towards 2 from the left and 2 from the right. It's smooth. There's no sharp point. It's continuous and it's differentiable at 0. Its derivative exists, and the derivative going in is the derivative going out. And so the function is differentiable at 0. So any answer that has 0 in it is gone. because we're saying where it's not differentiable at. So the question is, what's going on at 2? And at 2, the derivative has different values. The derivative is 12 plus a half minus 1, and then 12 plus a half plus 1. They disagree. It's not differentiable at 2. I mean, just think about what absolute value does. It's going to have a cusp. So, not differentiable at 2. And, of course, we already said not continuous, so not differentiable at 1. So 1 and 2 is the answer. And that was the only one left. I guess we could have thought, maybe could have had that if it was differentiable at 2. Yes? There might be some way to cook it up where it would work out. But pretty much, yeah. I don't want to say every time or always. I'm always careful with it.
We made that assumption on the test.
You have to show it. Sorry. Next question. Oh, yeah.
If there was only one answer that had one in it, you wouldn't have to figure out what if the derivative or anything if it was not continuous at one, or would you still have to keep the derivative of those and show that it wasn't?
I recommend you got to fully answer the question, so go through it. Okay. Spring 2012, number 2, 16, and 20. Yeah, this is just to show that the integral is, it's just plug in the h, plug in the b, and show that the area is 2/3 of, yeah, it's just a plug and chug kind of thing. I don't know. Yeah. I mean, I can get you started on it, but it really is just a... And this is another one that we did last review session. So h is 8, b is 3, so the function is 8 minus 32 over 9x squared. The area under there, the integral from minus 3/2 to 3/2 of that function is the same as this base of b, this height of h, 2/3 of it. You have to show this. That basically that the area is 16. I'll let you finish that. That's number 2 on spring 2012. Number 16 on spring 2012. differentials question. We have estimate the volume of material in the cylindrical shell. Volume is equal to pi r squared h. And r is possibly a function of, so we have to do, it's kind of like a related, we have the length is 30, the radius is 6, the thickness is a half, r is 6. Now h is what I call the length, what they're calling the length, 30. And then there's something that's changing. The height is not changing. The height is staying at 30. But basically, the thickness here is representative of how the radius is changing. dr, the differential in radius, is a half of an inch. Okay. dh is 0. Okay. Now you want to know dv using differentials. You want to know dv for this function where h is the height, r is the radius, and pi is a constant. So if you want to think about it like this, we take the derivative with respect to r and get 2 pi r and then times the h times the dr. We could also get pi r squared h times the dh, but dh is 0, so we don't end up worrying about this whole part here. Yeah.
How is it though that dr is 1/2? It's not like that ring that's around the outside of the cylinder is just a 1/2.
I'm trying to estimate the change in volume. If I decrease, I'm trying to estimate the change in volume if I decrease the radius by a half. That's the thickness of the two.
Oh, okay, so that's the, like, between the two scenarios.
What is DH?
dh is a change in height. The height doesn't change. D is changing. I'll let you finish it from there. No, just plug in 2 times pi times 6 times 30 times a half. All right. It looks like number 20 was on Professor Wong's exam. Exactly. Fall 2008, number 1 and number 10. Fall 2008, number 11 and number 10. You have this function here. It asks about absolute, max, and min. Okay. Now, I was saying that we should go to a chart. We don't have an A and a B. So, it must be that the domain is the A and the B. As we go towards negative infinity, we have to figure out what happens. As we go towards positive infinity, we have to figure out what happens. Both cases, the function goes to 0. This function is x squared over e to the x squared. That's our function. As x gets big, the denominator ends up being so much greater than the numerator that it dominates, and as it gets big, the whole thing will get small. So as you approach negative infinity, it goes to 0. As you approach infinity, it goes to 0. So when it comes time for critical numbers in between, just any critical number from minus infinity to infinity. Anytime your derivative is equal to 0 or undefined, but don't do it as a quotient rule. When it comes time to take the derivative, you're better off doing it as a product rule. This is just so you can understand what happens as x goes towards infinity, and as x goes towards negative infinity, the function goes towards 0. Go back to the original x squared e to the negative x squared and take the derivative using the product rule, and you'll get 2x times e to the negative x squared. That is the derivative of the first times the second. Then you'll have the first, and now you want to do the derivative of the second. Don't think of bringing the negative x squared down. E doesn't work like that. When you have e, or any exponential function, you repeat the function as its derivative, and you multiply it by the derivative of the exponent. If your base is anything other than e, you got an extra natural log of that base on there. So this is the derivative of the second. When trying to do algebra with exponential functions, it's helpful to factor out. Both of these have an e to the negative x squared. Both of these have an x. Both of these have a 2. If you factor that out, from the first term you're left only with a 1. From the second term you have a negative x squared. So 1 minus x squared. That's your derivative. And you want to set this equal to 0. This is 1 minus x squared. That's equal to 0. Then x is plus or minus 1. And then out here, x could be 0. But this guy is never 0. Exponential functions. Unless you take and shift them some kind of way by adding or subtracting from the function. So we have 3 values. Negative 1, 0, and 1. At 0, your function is 0. At 1, your function is e to the negative 1, or 1 over e. And same thing at negative 1, because every time there's an x is squared. So the absolute maximum value of your function is e to the negative 1. Same exam, number 10. Is there a question about that? Yes? It depends on your grader. Officially, you need to prove that you have maximized or minimized the function. So you can go with the another kind of argument, but you'd have to just explain this whole situation why it has to be the biggest the function ever gets. Yes? I didn't substitute infinity. Never do that. You can't treat infinity like a number. I did a limit as x went to infinity, and as x went to negative infinity. Technicality, you know. Yeah, don't do that though. Don't plug in infinity. You can't treat it like a number. Same exam, number 10. This is that same setup. Is the function differentiable? First off, is it continuous? So we make sure that happens. And then, is the derivative continuous, basically? Does the derivative meet up? So at x equals 1, the function's going towards 3a plus 2b plus 1 as you go towards 1. From the other side, as you go towards 1, the function's going towards a minus 4b, minus 3. If these aren't equal, I don't have a chance to be differentiable. So it better be true that 3a plus 2b plus 1 is equal to a minus 4b minus 3. It doesn't give me directly what a and b are, but it tells me a relationship that has to be true about a and b. It tells me that 7a, no, that's a lie, 2a plus 6b has to be negative 4. Has to be true. Has to be true. And then when it comes time for the derivative, if there was a derivative, I do it piecewise, and I would get 6ax plus 2b, 4ax cubed minus 8bx minus 3. That would be the derivative. If there was one, I need to make sure they meet up. So I got to do the same thing with that. At 1. What's the derivative going towards? 6a plus 2b. On the other side of 1, 4a minus 8b minus 3. Those two guys better equal. And then it's an algebra question. This tells me that 2a plus 10b is negative 3. I take these two together. And I only want what b is. I don't really care what a is. I want what b is. So I go solve b by subtracting these equations one from the other. Okay, go solve. Solve this system for b. Question about that? Spring 2012, number 6. Same thing. For the hypothesis for the mean value theorem, you have to be continuous and differentiable. Exact same thing. Make sure that the function is continuous, it meets up at the broken parts, and that its derivative is equal to each other at those same broken parts. So the hypothesis of the mean value theorem is that you have to be continuous and differentiable. So I won't do that question. It's a repeat. Is it okay? Tausner, midterm 2, number 4. Suppose g of x is a function with g prime of x equal to e to the x squared. If h of x is g of log x, what is h prime of that? So h prime of x equals g prime of log x times 1 over x. That's your classic chain rule question. Take the derivative of the inside of the outside with the inside plugged in and multiply by the derivative of the inside. We don't know what g is, but we know what g prime is. G prime is e to the x squared. So e to the log x squared. This is what it means to have log x replacing x. I multiply that by 1 over x, so the answer is e. Don't think you can bring that 2 down or cancel that 2. It's the entire log x that's squared. If it was only the x that was squared, then you could bring the 2 down. But it's the entirety of log x that's squared, and that's how we get that answer. Fall 2009, numbers 2 and 3. Integration problems. I'll get you set up on them. We almost made it to the end of the list. It's crazy. It's efficient. Two ways to do number 2. I do believe that the derivative of the inside is the outside. Right, some constant. What is this inside? This inside is x to the negative 2/3 plus 1. And the derivative of x to the negative 2/3 involves a x to the 1/3. You could do this with a u-sub. That wasn't my intent when I made this problem. My intent was to have you just distribute this guy across and just do the antiderivative of each one of those. But this is actually could be done with a u-sub. I don't know. I think it's better off just doing it this way. What is x to the 1/3 divided by x to the 2/3? If you do 1/3 minus 2/3, you get minus 1/3. So basically you're looking at x to the minus 1/3 plus x to the 1/3 that you're integrating from 0 to 8. That was my intent. But this actually could be done with u substitution. If you let u be the entirety, the derivative of it is negative 2/3 x to the 1/3. So negative 3/2 of du could take the place of x to the 1/3 dx, and you'll be integrating negative 3/2 the integral of u du. I like this way better, but you do however you want. Down here it's a u sub. You have to let u be the natural log of x because its derivative is 1 over x dx. It's the rest of this. And you'll be looking at u squared du. Just don't plug in these numbers because these are x numbers. You have to make a choice. Do you want to switch the numbers or switch the u's back to x's? And in class, I've been doing it as switching the u's back to x's. It's up to you how you want to do it, though. If some people just prefer to switch the numbers. If you do switch the numbers, then you plug into the limit. You plug the limits into the substitution. Sometimes that gives you them backwards, but you just got to be careful. So anyway, I'll let you finish this off. I have you set up for both. I intend for number 3 to be a U sub. There's no other way to do it. I didn't intend for number 2 to be a U sub, but it can be done with 1. I had just set up here. This is the easier way, I believe, to do it, though. And so we are officially done for now. Just make sure you get some sleep. Do not pull an all-nighter. You want your mind to be functioning at 9 a.m. So do what you need to do. All right? That's it.
Also remember, we have to be able to draw functions